Hello everyone, I'm Varun and I'm excited to present to you the expression tracker sentiment analysis for dyslexic kids using Hugging Face. This project aims to enhance learning experiences for dyslexic children by analyzing their emotions in real time as they engage with educational games. Using a pre-built model from Hugging Face, our system is designed to identify emotional states to meet each child's unique needs. Today, I'll take you through the main components of this solution, its underlying data structures, user interfaces, and the business logic that powers it. Now let's begin by looking at the core components of the solution. We have structured the system to include four primary modules. The first being the gameplay module. This module hosts educational games, followed by the facial expression detection model. This captures video input from the child's webcam in real time, providing essential data for emotion analysis. Next, coming to the emotion recognition module. Here, we leverage a pre-built model from Hugging Face. This module takes the webcam input and classifies emotions such as frustration, happiness, or boredom, making it the core driver of our adaptive features. Further, going to the feedback and reporting module, this module tracks emotional and gameplay data over time, presenting insights for therapists and educators on the child's engagement and learning progress. Now let's look at how these components communicate. The front end captures the webcam feed and sends it to the backend. The backend processes the video input using Node.js and communicates with the Hugging Face API for emotion detection. The database stores emotional data and gameplay metrics in MongoDB, allowing us to track emotional responses over time. This setup creates a feedback loop where real-time emotion detection enables the representation of the emotional data, which is in turn used for further studies. Now moving on to the underlying data structures, our database is structured to store different types of information that supports the system's functionality. Here are the main structures. The first being user profiles, which stores each child's emotional baseline and gameplay history, enabling us to provide a personalized experience. Second, facial expression data. It captures each frame of video as a timestamped data entry labeled with the detected emotion. The third, emotion metrics, which stores the records during the duration of each detected emotional state, which helps us understand engagement levels over time. The last, but not the least, being gameplay data. It tracks scores, levels, and time spent on each task, allowing us to correlate performances with emotional states. Now, moving on to the tech stack used. Our tech stack for this project is based on the MERN stack, chosen for its flexibility and scalability. The front end is built with React.js for responsive interactive interfaces. The backend uses Node.js and Express to handle API requests and communicates with the emotion recognition model. The MongoDB stores all emotional data, gameplay records, and user profiles. For emotion recognition, we use a Hugging Face pre-built model which allows for real-time analysis of emotional states. Moving on to the roles in the app. This project serves two primary user groups, each with specific needs. The first being children, who are the end users. They interact with the game. Next, the educators or therapists. This group accesses reports and analytics that offer insights into the child's emotional and learning progress. They can see trends over time, helping them understand when the child is engaged or frustrated and when intervention might be needed. Moving on to the interfaces to be developed. The interface within this project are designed to provide a seamless, intuitive experience for children, educators, and administrators. Each interface serves a different purpose, focusing on usability, accessibility, and responsiveness to the child's emotional needs. Let's go over each one. The first being gameplay interface. This interface is the primary interaction point for the child, enabling them to play educational games. Since this is for dyslexic children, it is crucial that the interface is dyslexia friendly. This means using larger, easy to read fonts, high contrast colors, and avoiding unnecessary visual clutter to keep children focused on the game content. Now, coming on to the analytics dashboard. This dashboard is for parents, educators, and therapists, providing comprehensive insights into the child's emotional trends and gameplay performances over time. The dashboard needs to be data rich yet easy to interpret with clear visualizations that summarize complex data effectively. Charts, graphs, and trend lines are ideal for displaying information in a way that's both accessible and meaningful. Coming to the datasets used, In our project, we use several datasets to achieve accurate emotion tracking and analysis. Let's break them down. Our main source is the FER 2013 dataset. This is the core dataset for our emotion recognition sourced from Kaggle. It contains 48 by 48 pixel grayscale images of faces categorized into 7 emotions: angry, disgust, fear, happy, sad, surprise, and neutral. Each image has been standardized so that the face is centered and occupies roughly the same space, improving consistency for emotion detection. With over 28,000 training examples and nearly 3,600 test examples, this dataset enables robust training and testing of our emotion detection model. Coming to the input and output screens. For the input screens, we use the webcam to capture real-time facial data as children interact with the gameplay interface. Now, coming to the output screens, emotion feedback is displayed to the educators. Additionally, therapists and educators can access detailed post-session reports that provide insights into the child's emotional states and gameplay performances. Now, let's go through the workflow of our project. First, the webcam captures the facial data as the child engages with the game, which serve as input for the emotion recognition system. Now, the emotion recognition. The data is sent to the Hugging Face model, which classifies emotions in real time. Coming to the data storage, emotional data and gameplay metrics are stored in MongoDB for further analysis and reporting. Finally, the reporting and feedback. Educators and therapists access visual reports that display trends in emotional engagement and learning process, helping them make informed decisions. Moving on to business logic. The business logic behind this project focuses on providing a personalized, adaptive learning experience that benefits dyslexic children and supports continuous improvement in the game design. Let's break down the core principles. First, creating better games. By analyzing emotional responses during gameplay, we gather valuable insights into what works and what doesn't. This data helps game developers identify which element leads to frustration, engagement, or boredom. Now, moving on to personalized learning experience. Each child's emotional and gameplay data is tracked, stored, creating a unique emotional profile. This system uses this data to tailor the learning experience, adjusting game difficulty and pacing in response to individual emotional states. Moving on to real time game validation. Each gameplay session serves as a test of how well the game mechanics support learning and engagement. As emotions like happiness, frustration, and surprise are detected, they validate different aspects of the game. Based on these insights, future game design can be refined to better meet the needs of dyslexic children, fostering a more engaging and effective learning environment. So, coming to the end, here I have provided some of the links to research papers and articles which we have proactively utilized to gain insights regarding some crucial parts of understanding the users, helping us to understand their requirements more effectively in order to make a better software. Since we have reached the end, in conclusion, our project is a unique system that combines real time emotion detection with adaptive learning to create an engaging, personalized education experience for dyslexic children. By leveraging a pre-built Hugging Face model, we can accurately detect a range of emotions, from happiness to frustration, and use this data to tailor gameplay in real time. Our approach not only enhances learning by responding to each child's emotional state, but also supports therapists and educators with detailed insights into emotional trends and learning progress. With the FER 2013 dataset and a flexible MERN stack, we ensure that the system remains robust, scalable, and capable of delivering meaningful, data driven outcomes. Looking ahead, we see potential for continuous improvement in game design, more refined personalized learning paths, and better validation of educational tools through emotion analysis. Our project is not just a tool for tracking emotions, it's a comprehensive system for creating support, emotionally responsive learning environments for children with unique learning needs. Thank you for your attention, and I'm happy to answer any questions.